So welcome back again, ladies and gentlemen. We're going to now try to take an extension of the vertex form of a quadratic. This is the vertex form that I've written. It looks like you were taught y equals a x minus h squared plus k. If you're looking at our new handout, it's also y equals a x minus p squared plus q, p's and q's, depending who you have, right? So this equation is here for us to work with. Now, first of all, before I attempt this question, I think a lot of you realize this parabola has two roots. And the reason why a lot of you know this has two roots is because the a and the k are different signs. The parabola, in this case, if we were to just write it as y equals 2 times x plus 3 squared minus 32, a lot of you realize the parabola opens up because the a is positive, and the coordinates of the vertex are -3 and -32. So to visualize this, -3 is over here. That's not important. -13 is exaggerated. -32 is over here. And clearly, when it opens up, it's going to cross the x-axis twice. Everyone understand that? A lot of you hopefully remember that from grade 10. It's a fast way to do it. When the a and k are different signs, or the a and q are different signs, they'll have two real roots. Conversely, if a and k or a and q are the same signs, there's no real roots. And if k or q is equal to 0, there's one real root. We'll explain that in a moment. Back to this though. We have 2 times x plus 3 squared minus 32 equals 0, and it says to solve. And again, some students don't know what to do. So one more time. What I'm writing is the acronym for BEDMAS. But you do it this way when you are doing evaluations. But technically, when you are solving, you go in this direction. Don't get me wrong, you can definitely deal with that 2 first. You can also deal with the squaring, you could definitely, but most students actually realize the way that we use SAMDEV, or solving in this direction, you deal with any adding or subtracting first. In this case, this is -32, and what are we going to do? We're going to add 32 to both sides. Notice what we get? We get that. What do we do next? I think everybody agrees we're going to divide by 2. I think someone said it. I can't. Was it you when I said that? And we get 16. And this is where the conundrum lies. But some of you have already been trained well from grade 10 and now from grade 11. The opposite of squaring is square rooting. Now you have to be careful here. When you square both sides, the left-hand side is for sure x plus 3. But the right-hand side, you have to be careful. This is a solving question. It's not an evaluation question. Can someone please maybe recall what is the answer I'm going to write here? Be careful. Most students actually get this wrong. Omar, want to check? 4. Sorry? 4. So close. The answer is not 4. Or it's not only 4. The answer for this is plus or minus 4. And slowly, some of you are understanding the connection to our quadratic formula later in our video series that we're going to be doing. So let's just take a pause. Some students find this very annoying. In grade 10, for sure, you've never really seen a plus or minus sign. So some students will do it like this. X plus 3 is equal to positive 4. X plus 3 is equal to negative 4. And solve this. And notice this is now easy to solve. In this first scenario, subtract 3 to both sides. X is equal to 1. How about in this scenario? Subtract 3 to both sides. X is equal to -7. Notice, when x is 1 or -7, the answer will be 0. Notice, this is a mechanism of using radicals. It's kind of like unraveling an onion. I just did a Shrek analogy.